sorry, I'm sorry. So so inorganic chemistry का last topic जो है of 11th standard, that is group 14. Okay, the last topic of inorganic chemistry group 4 11th standard is group 14, and we will try to cover it in about 2 days time. So it should not take much, it should not take a lot of time. We should be able to cover it very easily, very properly. Okay, so chalo, let's start today's session and let's see what group 14 has to offer us. So group 14 को हम बोलते हैं carbon family. Okay, group 14 is called carbon family. Why it is known as carbon family? Because the first member is carbon. Okay, so carbon, silicon, germanium, tin, lead. Carbon, silicon, germanium, tin, lead. So carbon is present in the second period and lead is present. So this is present in the second period, third period, fourth period, fifth period and sixth period. Seventh period के element को हमको consider करना नहीं है because that is radioactive. We will consider elements only until the sixth period. So carbon, silicon, germanium, tin, lead. If I look at the valence shell, then the valence shell configuration is NS2 NP2. Okay, the valence shell configuration is NS2 and NP2. Clear? Let's move ahead. First we discuss the metallic nature. अगर हम metallic nature की बात करें, then carbon is non-metal in nature. Okay, carbon is a non-metal. Silicon is also a non-metal. However, germanium is metalloid. Okay, germanium is metalloid, and tin and lead are metals. Tin and lead are metals. So there are two metals, two non-metals and a metalloid. An even distribution, अच्छा distribution है. Carbon and silicon, both of them are non-metals. Germanium is metalloid, tin is metal and lead is also metal. So as we go down the group, the metallic character increases. And one very simple idea that why the metallic character increases is because जैसे नीचे आते हो, the size of the atom increases, which we can observe in the atomic radius. As the size of the atom increases, it becomes easier to remove the electron. So as you can look over here, as you move from carbon to lead, you can see that the size is increasing. Okay, so carbon to silicon, silicon to germanium, tin and lead, it is increasing. So there's a considerable increase in covalent radius from carbon to silicon, isn't it? Can you see that there's a huge increase? There's a good amount of increase, but the amount of increase is not that much in the next case. So silicon to lead, a small increase in radius due to the presence of, so because of poor shielding of d orbital electrons, the radius does not increase. The radius does not increase very to a very enormous extent. So the delta in radius is quite less. Okay? So as you move from carbon to silicon, the increase is huge, but going from silicon to lead, the increase is not that much. अब देख रहे हो बहुत कम increase हो रहा है. Okay, however, there is an increase. Nevertheless, there is an increase. So we will go with the idea that as we go down the group, the size of the atoms increase. Okay. And next, when we talk about the ionization energy, now as we consider these ionization energy, तो हम क्या expect करेंगे? As I go down the group, the ionization energy should decrease, isn't it? The element with highest ionization energy or ionization enthalpy should be carbon. Okay, there Dhamu Mishra, beta, there is no exception over here. Okay, there is no exception over here. In this group, there is no exception. There could be some, there are certain exceptions which are present in different groups, but not over here. Okay, so if we talk about the ionization energy, the ionization energy should decrease down the group. You can see that. So it is very, very high for carbon, 1086, but it decreases. Okay, it decreases. However, you can see that when we take tin and lead, then tin has in fact lesser ionization energy than lead. So lead में थोड़ा सा increase कर जाता है. So first ionization energy of group members is higher than the corresponding of group 13. That is quite obvious, because you are removing an electron from a smaller atom. So small decrease in IE from silicon to germanium and slight increase in IE from tin and lead is due to poor shielding effect. So the moment we go to lead, because of the poor shielding effect, the effective nuclear charge is slightly higher, and so removing the electron becomes a little more challenging. So that is the reason tin becomes that element which has the smallest ionization energy. So please do remember, as we go down, it should decrease. So the expected trend is carbon should be maximum, then should be silicon, germanium, tin and lead. Lead should be minimum. However, there is a small change over here. There's a small change over here. Tin has in fact lesser ionization energy than lead because of poor shielding of f orbital electrons. So you can see these values. You do not have to remember the values, you just have to remember the trend. Okay, you just have to remember the trend. चलो लेट्स मूव ऑन टू इलेक्ट्रोनेगेटिविटी. अब इलेक्ट्रोनेगेटिविटी की बारी आती है. तो व्हाट हैपेंस टू इलेक्ट्रोनेगेटिविटी? इलेक्ट्रोनेगेटिविटी शुड बी हाईएस्ट फॉर कार्बन एज वी गो डाउन. सो नॉन मेटल्स के लिए इलेक्ट्रोनेगेटिविटी मैक्सिमम होनी चाहिए. मेटल्स इलेक्ट्रोनेगेटिविटी शुड बी मिनिमम. सो नॉन मेटेलिक एलिमेंट्स, the smallest non-metallic element in this group is carbon. So carbon should have the highest electronegativity. Carbon's electronegativity is in fact 2.5. It keeps on decreasing, but you can see that the electronegativity does not decrease a lot. In fact, as we go from silicon, germanium and tin, all of them have almost the same electronegativity. So electronegativity for elements from silicon to tin are almost the same due to Z effective. So what happens is the size is increasing, but the effective nuclear charge is also increasing. So both of them counterbalance each other, and so the electronegativity remains almost constant. Okay, lead has slightly higher electronegativity. It's an aberration to the usual trend. Actually tin से कम होना चाहिए था, but slightly higher because of poor shielding of f orbital electrons, and which increases the nuclear charge. Okay, okay, so slightly higher because of increased nuclear charge. Slightly higher because of increased nuclear charge. ठीक है? Now Again, oxidation state and inert pair effect. We have discussed inert pair effect in group 13. मैंने क्या बताया था आपको? Inert pair effect is the reason which we utilize to suggest, or it is a phenomenon that we observe when an element does not show the highest oxidation state possible for that group. Okay, it tries to show the lower oxidation state. So if I take a NS2NP2 configuration, the maximum oxidation state should be +4 and minimum positive oxidation state would be +2. Minimum positive oxidation state will be +2. Now +4, why? Because electrons can be removed from Ns to Np2, and if it is removed only from Np2 and not from Ns2, then it is +2. Okay, man, I do not know when would JEE 2021 being held. Like, I am not in the organizing committee. Nobody can answer that unless and until NTA announces it. Nobody can answer it. Okay, so NTA does not give the information to me. NTA will give the information when the time comes. Okay, they have not given the information yet, so we do not know. Okay, so you have taught metal carbonyls and also stability. Man, metal carbonyls, we have already discussed synergic bonding. Okay, we have already discussed effective atomic number. These are the only two things that you have to read in metal carbonyls. Okay, about stability, that's an easy section, you can read it on your own. Okay, just follow NCERT for that. I've taken the most challenging sections. Okay, let's move ahead. So oxidation state can be of two values. It can be +4, it can be +2. +4 is because of NS2 and NP2 getting unpaired, and if only NP2 gets unpaired, it will be +2 oxidation state. So p block elements show higher group oxidation state, so lower oxidation state attributed to inert pair effect. So if I look at lead, for lead +2 oxidation state is more stable than +4, but if I take carbon, then for carbon +2 is less stable than +4. Okay, the +2 oxidation state the stability of the +2 oxidation state increases as we go down the group. Okay, it is impossible to crack JEE in 2 months. There are students who have been preparing for 2 years, man. Okay, it's impossible to crack JEE in 2 months. Okay, let's look at this question. Which statement is correct with respect to the property of elements with increase in atomic number in the carbon family? If I increase the atomic number of carbon family, that means going down the group. Increase in atomic number of carbon family, that means going down the group. The metallic character decreases, the stability for +2 oxidation state increases, the ionization energy increases, the atomic size decreases. The right answer to this question is B. The stability of +2 oxidation state increases. As we go down the group, the tendency to show +2 oxidation state increases because of inert pair effect. Ionization energy in fact decrease करना चाहिए. Atomic radius increases. Metallic character increases. It turns from non-metal to metal. Okay, Clear? The right answer should be B. Next, the elements of 4A group or group 14 have 4 electrons in the outermost orbit. They form M4 plus ions, form M4 plus and M4 minus ions, exhibit oxidation state of +4 and +2, exhibit oxidation state of +4 only. What do you think will be the most appropriate answer? Exhibit, what should be the right answer? They are group 14 elements. So the maximum oxidation state can be +4. The minimum positive oxidation state can be +2. The right answer should be C. So exhibit oxidation state of +4 and +2. Okay, right answer should be +4 and +2. Okay. So let's go on to the next part. Let's discuss some other physical properties. So other physical properties में क्या आ जाती है, उनका state आ जाता है. Okay, if you look at the state of group 14 elements, group 14 elements are solids. Group 14 elements are solids. Clear? Group 14 elements में कोई liquids नहीं है. All of them are solids. Okay, all of them show catenation except lead. Lead does not show catenation. Okay, lead does not show catenation. All their halides undergo hydrolysis because of presence of d orbital. This we'll read later on, that how does this hydrolysis takes place. For now बस याद रखो कि hydrolysis of their halides is possible because of presence of vacant d orbitals, except carbon. कार्बन के हैलाइड्स को आप हाइड्रोलाइज नहीं कर सकते. फॉर एग्जांपल CCl4, you cannot hydrolyze CCl4. You cannot. Hydrolysis reaction involves the displacement of the halogen by water. That you cannot do in carbon halides because carbon does not have vacant d orbitals. Other elements have vacant d orbitals, so उनके halides को हम hydrolyze कर सकते हैं. The melting point of group 14 elements are much higher than that of corresponding group 13 elements because the atoms become smaller. Okay, the atoms become smaller. Clear? So these are some few physical properties. याद रखो important physical properties आपको क्या क्या पढ़नी है. Size, oxidation state, electronegativity, ionization energy, state, and comparison with group 13 in terms of melting point and boiling point. Now let's quickly go through few chemical properties. Now if I look at their chemical properties, and the first chemical property, the first general chemical property that we would talk about is their reactivity with air. How do they react with air? So they react with air to give an oxide. Okay, all of them react with air to give an oxide. Now, how many different types of oxides can be obtained? That is very, very important. If I take carbon, then carbon can form neutral oxide, that is carbon monoxide, acidic, which is CO2, and it can also form an acidic oxide, which is C3O2. It is known as carbon suboxide. Please do remember the formula of what is the structure of C3O2, because C3O2's structure has been asked multiple times in JEE Advanced as well as in NEET. So C3O2, what is C3O2? It is carbon suboxide. Silicon can form SiO2, which is acidic, and SiO only at a very elevated temperature, but the most stable oxide I would say is SiO2. Germanium forms amphoteric oxide. It's a metalloid. जो metalloid होगा, that has intermediate properties of metal and non-metal, so it forms a amphoteric oxide. Forms amphoteric oxide. All of the metals also form amphoteric oxide because these metallic these oxides which are formed These oxides can react with acids as well as bases. Tin oxide HCl के साथ भी reaction करेगा. It can react with NaOH as well. If it reacts with HCl, I'll get chlorides. If it reacts with NaOH, I'll get stannates. Okay, plumbates. So stannate, plumbate will be obtained with hydroxides. Chlorides, sulfates will be obtained with acids. Okay, so amphoteric. So is this chapter very important? Shalini is asking. Yeah, I would say like a chapter is easy. You should not leave it. I cannot label the chapter as important or not. Every topic has got its own relevance. If you are getting questions from a particular topic, then it is important. You do get questions from carbon family, yes, so it is important. Reactivity towards water. So the non-metals are unaffected by water, and the metalloid as well. Non-metal and the metalloid are unaffected by water. Okay, unaffected by cold water. I would say unaffected by cold water. Unaffected by cold water. If you take carbon in cold water, it will not be affected. Silicon in cold water, not affected. Germanium in cold water, not affected. The most that can happen is only at elevated temperature. Okay, तो अगर आप elevated temperature पे लेते हो इनको and you take water in the form of steam, then maybe carbon and silicon can react, but not under cold condition or under room temperature condition. Room temperature मतलब इसी room temperature इस condition में if I take some carbon and I put it in water, there will not be any reaction. But to make this reaction happen, I have to increase the temperature and convert water into steam. Okay, lead is not affected by water due to formation of a protective oxide film. Lead is a metal, the most reactive metal of this group. This metal will form oxide, and if it forms oxide, the surface will get covered with it and no further reaction will take place. You have to dissolve the oxide so that any reaction can occur. Tin decomposes steam into tin oxide and hydrogen gas. So अगर tin oxide को भी अगर आपने react कराना है, okay, sorry, tin should not be tin oxide, it should be tin. If you take tin, then tin will react under elevated temperature condition where you have steam, water in the form of steam, and that will create tin oxide and hydrogen. Silent Skiller, how to join Vedantu crash course. Man, please do check the community page. Over there we have posted how to join the Vedantu crash course. Okay, please do check the community page. All the notices are being put out over there. You can navigate to the Vedantu web page, use the coupon code and enroll yourself in a crash course. Okay, the next one is reaction with hydrogen and halogen. Okay, reaction with hydrogen and halogen. So among the general chemical properties, ये हमारे last general chemical property है. इसके बाद whatever we would be reading will be specific properties, like properties of halides, properties of oxides. General properties, among general properties, this is the last property. So if I take hydrogen and halogen, so I'm moving down the group from carbon to lead, stability of +4 decreases stability, ये तो हमने पहले ही पढ़ लिया है. Oxidizing power decreases down the group. What is the meaning of oxidizing power? The meaning of oxidizing power is the tendency to oxidize something and reduce it oneself. Okay, tendency to oxidize something and reduce oneself. So oxidizing power decreases down the group due to inert pair effect. Why does it decrease due to inert pair effect? आप किसी और को oxidize कर रहे हो and you are reducing yourself. No, it decreases. Okay, these elements form two types of halides. कितने तरह के halides बनाते हैं? So they form halides of the type mx2 and mx4, and most of these mx4s are covalent. So CX4, CH4. So whether it reacts with hydrogen or whether it reacts with halogen, forms similar type of compounds. So carbon forms CH4, silicon forms SiH4, germanium forms GeH4, SnH4, PbH4. These compounds are formed. Sir, good morning. Please tell me, after completing SNP block, can we go straight to DNF block? You can go straight to D block, there's no problem. But if you're in 11th standard, you will study D block only in, you will not study D block in 11th standard, you will study D block in 12th standard. Okay, but if you're in 12th standard and you're doing a revision, then yeah, you can complete SNP and directly go to D. There is absolutely nothing new that you have to study between these two things. Okay, and if I take halogens, so because carbon and silicon plus two oxidational states are not very stable, so they form CX4 and SiX4 kind of a salt halide. Germanium, tin and lead can form +2 halide and +4 halide. So GeX2, GeX4, SnX2, SnX4, PbX2, PbX4. They can form these. Okay, so this is the last general chemical property that we have to study. Okay, the next class will involve discussion around some specific compounds like halides of group 14, silicates and silicones. We will discuss these few things and allotropes of carbon, because these are some specific features of elements of group 14 that are usually asked in examination. We do not have to study everything. We have to study things relevant to the examination. Okay? So with this, I will end today's session. We had a very quick, very simple, very short discussion around group 14. It's easier to remember group 14 compared to other groups, and please do not ignore it. Okay, so chalo guys, bye bye, have a lovely time. Please do join me in the next class where we will discuss specific compounds of group 14, and that will be the last class of group 14. Okay, chaliye, bye bye, have a lovely time.